Hi guys. Hey, we haven't had a video lesson in a week or so, today is a good day for us to get started again. This lesson is going to be on compression and compression ratios. So just a brief little video here to help us understand a little bit about compression ratios. We talked about the engine mechanical part and the fact that the engine has 4 strokes. One of the most important parts of the power or the operation of the engine is the compression that the engine or the cylinder can produce. Without good compression, then we will not have any kind of explosion, and therefore the engine does not want to run. So we talked about the fact that the valves need to be closed on the compression and the power stroke so that it can trap that pressure in there. So what is compression? So as we talk about compression or the compression stroke, as the piston rises in the cylinder, it takes all this air and the fuel that has been collected in the cylinder and compresses it or squeezes it, as we talked about in the 4 different strokes of the engine, squeezes it into a small space. So all of this area here, as the piston comes up, it squeezes the fuel mixture right here in this small little space at the very top with the valves closed. And that is, there's pressure created when it does that. So in most engines, most motors, we want first off, that compression is measured, here in the US, is measured in PSI, or pounds per square inch. And so that pressure, that compression in most motors, rule of thumb, is going to be somewhere between 150 PSI and 200. Now, it will vary depending on the engine and the manufacturer, okay? So you certainly want to look the compression specification up on any engine that you're doing a compression test on. And we'll talk about that in just a minute. But rule of thumb is going to be somewhere between 150 and 200 PSI. Some of them are a little bit lower, some of them are a little bit higher. The second thing is, how do we check the compression in a cylinder? Where typically, the way that that's done is we remove a spark plug, and then we will thread in a compression gauge into that spark plug hole, and then we will crank the engine over. And as you crank the engine over, it builds that compression in there, and then the compression gauge that you have threaded into the spark plug hole will give you the pressure reading. Just like a tire gauge would give you the pressure reading on a tire. And so that's how we measure the compression in a cylinder. Now, what you want is, in addition, is even compression all the way across. So typically engines will have a normal compression reading, which, as I said, may be 150 PSI. Then they will have a minimum compression reading that is acceptable. And again, it varies from manufacturer to manufacturer, so you would have to look the specification up. But I've seen them say minimum compression reading of 100 PSI, which to me seems pretty low, but an engine will still run with 100 PSI. And then the last compression reading that they want you to check is a variation from cylinder to cylinder. So if we check the compression in cylinder number 1 and it reads 150 PSI, all the other cylinders need to be within typically 25% of each other. So if this is 150 and this one's 140 and this one's 160 and this one's 145, they're all pretty close as far as compression readings go, and so therefore that would be normal operation. What we're looking for if we're having engine running problems is a large variation. So let's say that we would have 150 PSI of compression in cylinder number 1, but in cylinder number 3, we would only have 90 psi. That's like a, I don't know, a 35% variation. So therefore, that would be out of specification. And so therefore, we would know that there is a problem. Now, the higher the compression, the better, or that's what we're looking for, is a high compression in these cylinders. So if this one's 150 and this one's 90, we know that the number 3 cylinder then has got some problem. We would have to go figure out what that is, but we would look for the problem here in the number 3 cylinder. The last thing that we want to talk about is compression ratio, and that's the other thing that engine manufacturers or people will talk about when it comes to compression readings. And the higher the compression ratio, the more compression that the cylinder will produce. What is compression ratio? Well, the term that you typically hear is compression ratios of 10 to 1, or 10.5 to 1, or 12 to 1, or 9.5 to 1. What does that compression rating or ratio mean? Well, this is what it means. What we're going to do is we're going to take a cylinder, okay, and we're going to run the piston all the way up to TDC, which is top dead center. Top dead center. Now, what they do is they measure this space right here at the very top with the piston at top dead center. How much space is right in here? Okay, so we take our piston, run it up to top dead center, and we measure this space right in here from the top of the piston, right there, that area inside the top dead center. Then we will take our piston and we will move it all the way down to bottom dead center in the cylinder. So here we go, BDC, bottom dead center, and we're going to measure this space. So we'll simplify this for us, just for the sake of this discussion, okay? Let's say that this space here is 0.5 or 1/2 inch. Now again, the spaces are much smaller than that, and the equations are much more detailed than that, more specific, but this is to illustrate what compression ratio is, okay? Now we're going to go measure the space from the piston to the top of the cylinder when the piston is at bottom dead center. And let's say that this space now is 5 inches, okay? It's 5 inches. So now, how many of this space, 1/2 inch, when it's at top dead center, can we fit into 5 inches? So if we figured it out, or if you did the math, you would learn that you can get 10 of these spaces in this space. 10 top dead center areas can fit into bottom dead center area. So that would mean if you have 10 of them, now your compression ratio is 10 to 1. So that's what compression ratio means. How many of these spaces can fit into bottom dead center, the area of the cylinder? And there's an equation for that. If you guys go to go to Google and look it up, they'll give you the mathematical equation for that. I'm not all that concerned about it. I just want to understand what that means. Now, again, if we have smaller space here, So in other words, we can get more of these areas jammed into here, then our ratio goes up. So if for some reason this was 6, okay, that would mean that our compression ratio now is 12-to-1 because I can get 12 of these spaces stuck in this space here when the piston is bottom dead center. Now, again, the higher the compression ratio, the higher the compression is in the engine because you have more area or more air and fuel that you're going to pack into even a smaller space, which increases the compression. So that's your lesson on compression. Do the worksheet so that I know that you watched the video and understand what compression and compression ratios are. It's good to see you guys. Make sure that you stay clean and stay safe, and we'll talk to you soon.